Let's solve a few more problems before we go to the next concept. Right? Okay. So the next question is this one. Find the radius of curvature of this is the curve. Y square is equal to 4a square into 2a minus x divided by x, right, where the curve meets the x-axis. So the question here is, there is a curve given, y square is equal to 4a square into 2a minus x whole divided by x. Wherever this curve is going to meet the x-axis, okay, we need to find that point and we need to find the radius of curvature at that point. This is the given question. All right. Okay. So how to find, first we need to think how to find out the point where the curve meets x-axis. Okay, so this is the basic idea. Anyway, let me draw a small curve, right? Let's say this is the given function. Let's say this is the x-axis, this is the y-axis. Now if let's say there's a curve like this, right? In this particular curve there is a point here, right? This is the point where the given curve meets the x-axis, right? So the idea here is that at this particular point, right, at this particular point where the curve meets the x-axis, you can see height is equal to 0. Y becomes equal to 0 at that point. There is no height. Height is not negative, height is not positive, height is 0. X can be any value, we don't know what is the x value, we need to find out. Okay, so this is the idea, right? Just to make sure that the curve touches the x-axis at the point where y becomes equal to 0. Okay, so we'll start from there. So if the curve, right, meets the x-axis, this implies the y value at that point is equal to 0. So in the given function, that is y square is equal to 4 into a square into this, the y becomes equal to 0. So on the left hand side I'll write 0 because at the point where it touches the x-axis, that value is 0, y is 0, so y square becomes equal to 0. This is 4 a square into 2a minus x whole divided by x. So anyway, this is gone. 4a square is also going to the other side, which becomes 0. So now I have 2a minus x equal to 0 because of this. So what is x now? At that point where the curve touches the x-axis, its x coordinate is 2a. So x is 2a, y is equal to 0. So that's the point. So this point is 2a comma 0 where the curve touches the x-axis. So finding this was our first case. Anyway, we found. So the point where it touches the x-axis, the point of contact is, now I can write x is 2a, y is equal to 0. Okay, now this is the point at which we are supposed to find the radius of curvature rho. Okay, now let's simplify the given function first so that we can write it in a different fashion. So y square is equal to, they have given, this is 4a square into, this is 2a minus x divided by, there is another x. Okay, now let us try to simplify this first before we go ahead. So this is equal to, right, this is 4a square into 2a, that becomes 8 into a cube. There is a x in the denominator. correct, minus, see, 4a square into x, 4a square into x divided by x. So this x and x will cancel. So the given equation y square becomes equal to, in a simplified format, it looks like this. This is 8a cube divided by x minus 4a square. Okay, now when I have the function in this format, why we converted the given function into this format? It's just because uh, our intention is to get a dy by dx and d square y by dx square. In that format I am supposed to write. Okay, now let's try to write this. Okay, so differentiating, we normally differentiate this particular function with respect to x. All right, with respect to x. Now what happens, right? Y square becomes 2y into y1 is equal to 8a cube is a constant, right, into 1 by x, derivative will be minus 1 by x squared. So the ultimate term I can write is 8 into a cube divided by x squared. This is 2y into y1. Okay, but what I want to substitute in my equation of rho is only y1. So what I do, I take this to the other side. So that means this is minus 8a cube divided by 2y into x squared. So 2 cancel this as 4. So now I can write this is equal to minus 4a cube divided by x square times y. This is y1. Okay, now I need to find out, right, what is the value of y1 at a given point, right? So at the given point, that is 2a comma 0, in the sense x is 2a, y is equal to 0, right? What happens to y1? Let's calculate. This is minus 4a cube divided by, see, x is nothing but 2a, this is 2a square into, see, y is 0, right? So this is undefined, in the sense it becomes infinity, right? So y1 becomes undefined. This is a new case for us. We had never seen a case like this. So now you see, you will come to know what to do if we get an undefined function, right? So remember the point, whenever one of the term, maybe y1 or y2, right, whenever we calculate, if this becomes undefined, then we need to do the reverse way, in the sense find the reverse derivative, right? That means since y1 is undefined, I cannot go to y2 as well, right? Y2 cannot be calculated. Y2 will also get a y somewhere in the denominator, so that also will become undefined. So as soon as one of the term becomes undefined, we follow, right, we try to calculate the dx by dy. Okay, so let's calculate the x1. X1 is equal to, I want to calculate dx by dy. So what we do, we calculate the same term, we keep the same term, right? We had a y term, instead of that we calculate for x term, right? Differentiate the term x with respect to y. All right, so dx by dy, in order to do that, let me write something else now before doing this. So from the given equation, so I'll write what we have already calculated. So we know something. Okay, what we know is this one, that is y square. We already know y square is equal to, this is 8a cube by x minus 4a square. All right, this is what we already have. I will write a x now. From this I want to write x because I want to do dx by dy. So this implies, so 8a cube divided by x is equal to y square minus 4a square. Sorry, minus becomes plus. All right, now this implies, if at all you want to calculate uh, say x now, so x is equal to, x goes to this side, this is 8a cube divided by y square plus 4a square. Alright, so we have this term with us now. Right, now this is one option. From this we can write. Alright, so this means let's find dx by dy. So dx by dy is equal to, there is 8a cube, which is a constant, into, right, see, there is 1 divided by y square plus 4a square. This is the term. What we can try to do here is this, right? That is, keep the numerator as it is, right? So first you write the denominator. Denominator is y square plus 4a square. This is the denominator, into the numerator, right? Derivative of the numerator, which is, there is 1, so this becomes 0, minus the denominator as it is, that is y square minus, so I'll write the derivative of this first. So derivative of the, into numerator into derivative of the denominator, right? I'm trying to do this with respect to y itself. So you see, this is y square is 2y. Okay, this is the term, whole divided by, right? I can write y square plus 4a square, right? The whole square. Okay, I have this term with me now. Okay, so this means you can see that I'm going to get the term like this. So this is equal to 8a cube. So first term is 0 into minus 2y whole divided by y square plus 4a square, the whole square. Okay, so now I think we can reduce this by using the term x. Okay, x is nothing but, so I can see here 8a cube by y square plus 4a square is there, right? This is a x now, correct? So what I can write, if I multiply by another 8a cube I have, if I multiply and divide by one more 8a cube, okay, 8a cube divided by 8a cube. Why I am doing this? Because see this term, 8a cube by y square plus 4a square is a x. But I have one extra in the denominator. To get that, I need to write another term, right? Another term. So now this becomes easy for you to understand. So let me write in this way. So I'll write 8a cube. There are two such things. So I write a square, okay, into, let me write minus 2y as it is, whole divided by, see the denominator. In the denominator, I have the y square plus 4a square, the whole square. Okay, into, there is one a added 8a cube. Anyway, I'll write this as it is. Okay, now, so this means, this is what, you just look at this term. This is nothing but, there are x into x. This is a x square. So now, so therefore, this is equal to, I can simply write whatever is inside this red region by simply x square minus, right, minus x square, because there is a minus term, into, I write a 2y. In the denominator, I simply have 8a cube, out of which 2 cancels with 8 as 4. So you can see that we were writing dx by dy. So the first differentiation, dx by dy is equal to minus x square y divided by 4a cube. Okay, this is what is the dx by dy. Now, when I found dy by dx, I got the answer as 0. Okay, sorry, I answered as infinity. I didn't get the answer. That's why I went for dx by dy. So this is nothing but, so at what point? At the point 2a comma 0, at this point, what happens? So this is x1. Okay, x1. So x1 is equal to, calculate, this is minus x is 2a the whole square into y becomes 0 divided by 4a cube. So your answer is equal to 0. Okay, now we have this function x1 and our next intention is to calculate an x2. Okay, so x2 is nothing but d square x by dy square. So which function you are differentiating? Already we have an x1 here. You can see that there is a x1 here. This function itself I am going to differentiate now, right, to get the d square x by dy square. So let us differentiate. When you differentiate, I can see that there is a constant 1 divided by 4a cube is a constant. Then I have x square y. So it's a product. So differentiate x, first function as it is, differentiation of y with respect to y is 1. Okay. Then plus, keep the second function as it is, y, into differentiation of x square is 2x into x1. Okay. This is my term. Now I'm going to substitute. I don't want to simplify because I directly want to calculate at the given point 2a comma 0. At 2a comma 0, what happens to the x2? x2 is equal to minus 1 by 4a cube into, write the x term. X is 2a, 2a square is 4a square into 1 plus y into 2 into x1, but x1 is 0, so this is 0. So 4 cancels with this, a square cancels with this, so I simply have x2 is equal to minus 1 divided by a. I got both the values. Okay, now go to the equation of the radius of curvature. Therefore, this is the final step. Therefore, rho is equal to 1 plus x1 square whole to the power 3 by 2 divided by, this is x2. So remember, yesterday's equation was like this. We used to write rho is equal to 1 plus y1 square whole to the power 3 by 2 divided by, this is y2. Okay, this is the other equation. But when y1 and y2 do not exist, like in this case, we saw that y1 is infinity, so I cannot substitute that in this equation. So what we did, we tried to calculate the inverse derivatives. Instead of finding dy by dx, we found dx by dy. Dx by dy was denoted as x1 and its second derivative, that is d square x by dy square, is x2. I can simply substitute those values in this equation. So this is 1 plus, if you see the x1 became 0, so this 0 square is 0 whole to the power 3 by 2 is simply 1 into x2. What is that? That is minus 1 by a. So numerator is 1. 1 divided by minus 1 by a is nothing but this is simply minus a. Okay, so since it is a radius, you can take a magnitude. So magnitude of rho is magnitude of minus a, which is plus a. So this is the required answer. Okay, the question is, find the pedal equation of, this is the curve, correct? So the curve is r to the n is equal to a to the n sine n theta plus b to the n cos n theta. All right. Okay. So whenever our intention is to find the pedal equation, we'll always do the differentiation, right? So before doing the differentiation, I need to get the log term. So take log on both sides. This is n log r is equal to, I'll take the log on both sides of the whole thing because it's not a product, it's a sum, so I cannot split. So this is a to the n sine n theta plus b to the n cos n theta. Okay, once you have this, now we can directly differentiate. Let's differentiate and see what happens. So when you differentiate, this becomes n into log r is 1 by r into dr by d theta. This is equal to, so I have a log term present now. So whenever I have a log term, this has to be 1 divided by the same thing, that is a to the n sine n theta plus b to the n cos n theta, then the differentiation of the numerator. Okay, so what is that? That is a to the n is a constant into sine n theta will be sine becomes cos, so this is n cos n theta, okay, plus b to the n as it is, cos n theta differentiation is minus n into this is sine of n theta. Let me write it clearly. So what is there on the left hand side? I can directly write this as cot phi. So cot phi is equal to, let me write it in this way. This is cot phi, no, this is n cot phi, correct, because there is a n outside. N cot phi is equal to, this is n into, I can see a n common there, I'll take the n outside. So this is a to the n cos n theta minus b to the n sine n theta whole divided by, this is a to the n sine n theta plus b to the n cos n theta. Okay, now I can cancel this and this. So this implies I am going to get the cot phi. So cot phi will be a to the n cos of n theta minus b to the n into sine of n theta whole divided by, this is a to the n sine of n theta plus b to the n, this is cos of n theta. Okay, we got till here. Now we'll consider the general format of the pedal equation. Okay, so in general, okay, let's start with the pedal equation. What is a pedal equation? Most general format, we know that this is P is equal to R into sine phi. I don't have a sine phi, somewhere I have a cot phi, but definitely I can convert cot phi into, right, some other format, but may not be the sine phi directly. So what I do, I try to write its different format, that is I'll write 1 by P. What is 1 by P? 1 by P will be 1 by R into 1 by sine phi, in the sense 1 by sine is nothing but, if you remember, this is cosecant phi. Okay, short while you will understand why I'm writing in terms of cosecant, not in cos or tan or any other function. Okay, this is a very peculiar case. Now what I did, if I do simply cosecant, it's of no use for me, right? So I'm trying to bring the square here. So I square both sides. So squaring this equation, I get, this implies 1 by P square is equal to 1 by R square into, say this becomes cosecant square phi, right? I know that I know the value of cot phi, right? So that's a clue now. The idea is we use a trigonometric identity, that is, if you have a cosecant square theta, I can replace it as 1 plus cot square theta. So you see now, this is the idea. When I have this particular function, right, this means I'll go back because I know what is a cot phi. Cot square is simply squaring of the right hand side, correct? So that gives me a cot square. So now let's use that idea to write this. Therefore 1 by P square is equal to, this implies 1 by P p square is equal to 1 by r square into what? Into now this is 1 plus cot square phi. Alright, let us substitute. So therefore, this is 1 by p square is equal to 1 by r square into this is 1 plus, write the cot function whatever we had, square it and write it. So that means it is a to the n cos n theta. I think we had a minus b to the n sine of n theta. This was the numerator of cot phi, and I'll write the denominator as well, that is a to the n sine n theta plus b to the n cos n theta. Alright, I need to square, so I'll write the squares separately because it becomes easier for me to take a common denominator. Alright, so this means this is equal to 1 by r square into, now I take a common denominator, whatever is the denominator will come at the location of 1. So this is a to the n sine n theta plus b to the n cos n theta. This was the denominator which was actually having a square plus the actual numerator which is already there. I'll write that once again, a to the n cos n theta minus b to the n sine n theta, this term square, and this is the closing of the bracket, whole divided by the denominator, that is a to the n sine n theta plus b to the n cos n theta, the whole square. Okay, now let's try to simplify this by using the a plus b whole square and a minus b whole square equations. Okay, let's apply that separately now. So anyway, I still have the 1 by r square outside, so I'll write that this is 1 by r square into, so let's try to write this. This is a plus b whole square, so a square, that means a to the 2n, right, into this is sine square of n theta, a square, plus b square is b to the 2n, this is cos square of n theta, a square plus b square, plus 2 into a into b, so that is plus 2 into a to the n sine n theta into b to the n cos n theta. Alright, so this is the first term of the numerator. Then I need to write the second term, so plus, right, write the second term, that is a minus b whole square. This is going to use that formula. So a minus b whole square is once again a square, so this is a to the 2n cos square of n theta, a square, once again b square, so this is b to the 2n sine square of n theta minus 2 into a into b, so 2 into a to the n cos n theta into b to the n sine n theta. Okay, this is the numerator, whole divided by, okay, this whole thing is a numerator. Okay, I wrote in 2 lines, please consider that. And in the denominator, I would like to keep the denominator as it is. I don't want to expand, right? You will come to know why soon. So this is a to the n sine of n theta plus this is b to the n cos of n theta, the whole square. Okay, in the numerator, what we have written, there is something which we can cancel. You can see this is plus 2an bn sine into cos. This is minus 2an bn sine into cos. It will cancel. Okay, after this, whatever is left over, I can see that I'll write the common terms. right? This and this term has a to the 2n common, all right, and this term and this term has b to the 2n common. Okay, let's try to write them separately. Let's try to extract and keep them separately. So this is 1 by r square into, first I'll take out a to the 2n common and I'll write whatever is left over. So in the first term, sine square n theta plus cos square n theta. This is the term. Plus, when I take b to the 2n common, I'm left with cos square n theta plus sine square n theta. So whole divided by, now what you have, you still have the same thing. This is a to the n sine n theta plus b to the n cos n theta, the whole square. Okay, now, so we know that this term cos square theta plus sine square theta, or cos square n theta sine square plus sine square n theta is 1. Same thing goes with this. Cos square plus sine square n theta is once again 1. So I don't have to write any those terms now. Those terms will become 1. So I am left with only this term, 1 by r square. In the numerator, I have a to the 2n, right, plus b to the 2n divided by, okay, look at the given function. The given function says wherever you see this term, if you see that there is a to the n sine and b to the n plus b to the n cos, you can simply write it as r to the n. Okay, I just have to look at that. If I see a to the n cos and b to the n sine function, right, I don't have to think further. Directly I can write that as r to the n. So now I can see that the same thing is here, a to the n sine, b to the n cos. So that means I can simply replace the whole function, whole term in the denominator by r to the n. This is on the other side, I have 1 by p squared. Okay, now, so I can write this as 1 by p square is equal to a to the n, a to the 2n plus b to the 2n whole divided by r to the power n plus 2. You can see that there is no theta present in this, and I am relating p and r. So this is the required Pedal equation. Anyway, definitely you can cross multiply and write the answer in a different format. Okay, so in that case you can try to write the Pedal equation in this format. So r to the power n plus 2, okay, r to the power n plus 2 is equal to this is p square into a to the 2n plus b to the 2n. Maybe this could be the other format. Okay, so okay, there's a small mistake in my calculation, so please see this. So I'm making a correction. So this is a square, so I have to write this as a 2n, not simply n. Please make a correction. So this becomes 2n plus 2. So this becomes 2n plus 2. Sorry for the mistake. Please correct. A to the n sine theta plus b to the n cos theta is r to the n, but I have a square outside, right? So there is a 2 outside, which means it is r to the power 2n. Alright, so considering that this is r to the 2n in the denominator, so every term becomes r to the 2n plus 2. Rest of the terms are still same, right? So r to the power 2n plus 2 is equal to p square into a to the 2n plus b to the 2n is the final answer of the required Pedal equation. The next question is to find the radius of curvature rho for the curve x square y is equal to a into x square plus y square at the given point minus 2a comma 2a. Okay, this is the question. So first we write down the equation, that is given equation is x square y is equal to a into x square plus y square. So normal differentiation will be done initially, that is differentiate with respect to x. What happens? X square y is a product, so x, whenever you have a product, write the first term as it is x square, right? Differentiate the second term, y becomes y1 plus keep this, differentiate the first term, that is 2x, keep the second term as it is, okay, is equal to, so a as it is, x square becomes 2a, not 2a is already written, sorry, so x square becomes 2x plus y square becomes 2y into y1. So let us expand this term now. So left hand side is still as it is, x square y1 plus 2xy is equal to, this is 2ax plus 2ay into y1. So if you remember, our intention here is to calculate the value of y1 only. So what we do, we try to take the terms containing y1 to one side, that is x square y1 minus 2ay into y1 is equal to, we have the 2ax on one side, I'll take the other term to the right side, that is minus 2xy. Alright, so this means you can take y1 common here, so y1 into x square minus 2ay is equal to 2ax minus 2xy. Okay, so this means what is y1? See, our intention was to calculate a y1, so now we got that. This is 2ax minus 2xy divided by, this is x square minus 2ay. Okay, so we got this. This is y1. Now we need to calculate at the given point. So let's just check what was the given point. Given point is minus 2a comma 2a. So at minus 2a comma 2a, we need to calculate y1. y1 is equal to 2a into minus 2a minus 2 into minus 2a into, this is 2a whole divided by x square, so this is 2a the whole square minus 2a the whole square minus 2a into y is equal to 2a. Now you can see that this denominator is there, right? Denominator is equal to 0. So you can calculate the numerator, but anyway that doesn't matter now because denominator is 0 means this is undefined. So I understand that y1 is undefined. Undefined in the sense something divided by 0. Actually infinity, but infinity we don't know the value, so we call simply it as undefined. Okay, so undefined. Now when we don't know the value of the y1, I need to go for x1. So now I'll tell you another way to calculate x1, right? So y1 is what? Y1 is actually, this is dy by dx. But what we actually need, I need to calculate x1 now. x1 is dx by dy. Dx by dy is actually inverse of this, right? So I simply can exchange the numerator and denominator of that equation to get this. Okay, it's a simpler way. You don't have to do any calculation. So this is nothing but x square minus 2ay divided by, this is 2ax minus 2xy. Okay, so I understand that I already know that the denominator is 0. So now the numerator is equal to 0. That's why x1 become equal to 0. 0 is valid. 0 is fine for us. Now I got x1. I need x2. What is x2? Therefore, x2 is equal to, this is d square x by dy square. Simply differentiate this term. How do you do? It's a quotient rule. So write the denominator, that is 2ax minus 2xy into the differentiation of the numerator, that is 2x into x1, right, minus 2a is the first term. Then minus, I'll write here minus the numerator as it is, that is x square minus 2ay into differentiation of the denominator, right? Differentiation of the denominator will be 2a x1 minus, see there is 2xy. So when I have 2xy, I have to differentiate, right? It's a product. So 2x into y becomes 1. Then the next term is 2y into x1. So I write 2x1 into y. This is the whole numerator divided by denominator square. So that is 2ax minus 2xy the whole square. This is the quotient rule, straightforwardly applied to the given particular quotient to find the derivative. Okay, now let us substitute now, because we have to find the value at a given specific point. So at, what is the point? The point is x is minus 2a and y is equal to 2a. At this particular point, let's calculate what is x2. x2 is equal to, wherever I see x, I'm going to put minus 2a. So this is the first term, 2a into minus 2a minus, this is 2 into minus 2a into 2a is the first term, into the second term, 2 into x is minus 2a, x1 is 0, minus 2a is the first term, okay, minus x square is minus 2a the whole square, minus 2 times a into y is a 2, okay, this into 2a, x1 is 0, minus 2 into minus 2a minus 2 into 0 whole divided by, this is 2a into minus 2a the whole square, okay, not whole square, sorry, there is no square, that's just 2a into minus 2a first term minus 2 into minus 2a into y is also 2a, this whole term this square. Okay, now let us simplify this. So the numerator is minus 4a square plus 8a square. So 8 minus 4 is plus 4. So you can see that we have the term, first term coming up, that is equal to 4a square. This is equal to 4a square. So the term is 0. So there is a 2 into this into 0 minus 2a minus 2a, and the second term 2a into 0, 2 into 0 is that, so minus 2a, this, okay, its whole thing is 0, so minus 0 whole divided by, so denominator is minus 4a square, and this is 8, okay, there is a square, so this becomes 4a square becomes, okay, this is 16, a to the power 4. Okay, now we got this. So this is simplified as, I can see that the a square into a will cancel with a cube, 1a remains. Then I have 4 into 2 is 8, cancels with 16 as 2. So I have minus 1 by 2a, that is x2. I got x1 equal to 0, I got x2. So therefore, my final calculation, rho is equal to, I just have to calculate this rho. Rho is equal to, this is 1 plus x1 square whole to the power 3 by 2 divided by the x2. So this is nothing but, this is 1 plus 0 whole raised to the power 3 by 2 divided by minus 1 by 2a. Okay, so numerator is 1 divided by minus 1 by 2a becomes, this 2a goes to the numerator as minus 2a. Alright, so that is the